Hello, my friends. So today we are going to see the latest invention and the greatest, of course, that is aimed to speed up the development of C# projects. So what do we have? What have we got? Let's navigate to GitHub. We'll see. And there are a couple of things I put into the shared repository because they are more open for collaborators and some other friends. And there are a couple of projects that I do under my own personal name because, frankly, I want to indicate that I don't need any help. But then again, this is a shared collaborative project that I'm going to share with you today. And what it is essentially a Roslyn compiler services for your coding agent. So let's have a look how it works. It is going to be rather easy to install, which is something I wanted to make for some time to make it a little bit easier. And yeah, I just need to fill in tons of forms, which I don't want to. But then how could I keep it? Oh, that's the way. And there's a trick I need to use here. I know this trick already. So great. I think now I can just install it. I've never tried this installer, so we'll see how it works. And if it works indeed or not. We can see, all right. And let's have a look. Okay, so we can see the registration results because by default, this tool already installs everything you need for both codecs and also your favorite cloud, whichever is your favorite, actually. I don't mind. So there you go. This is a very interesting installation that provides you 68 new skills. Is it too many? Is it not enough? Let's get into the details of what we got. And let's start with the living example. So I'm trying to push it as fast to the actual use as possible. Refactoring opportunities. So we'll see if I will trigger use of any of the new tools that have just been created or not. Maybe I will, maybe I won't. It actually uses memory, so might not trigger use of the tools I want initially. But we can see some of the things that could be used. This is the scenario where I would expect a new MCP tool to be used. So let's have a look at the project description. So we can see this is a temporary name. It's a C# MCP. So essentially it is a way of exposing compiler services to your coding agent. Very easy and hopefully very useful. I'm going to tell you why is it useful. Why do you want to have compiler services in your repository and your agentic coding sessions? So the first reason is that you are currently using best agent that would be maybe sometimes even more intelligent than your compiler. However, your compiler is deterministic, so it always does the same thing that will eventually do when compiling your software. So this is the best you can get. Is the closest to production code is what your compiler understands, not what your agent understands. But there are other benefits of using the compiler together with your agent. The benefits are the following. You can ban fewer tokens, because a lot of the work regarding refactoring, regarding renaming, finding unused symbols or used symbols, whatever you got, takes a lot of time to traverse a lot of code that would be traversed by your compiler anyway. That's not going to go away at all. But what will happen is that you're going to burn the CPU cycles rather than tokens if you offload some of the work that your coding agent needs to do to the compiler itself. So it's basically what it is. Compiler is deterministic. It will never hallucinate. It will never take a different approach. It will rather tell you whether a symbol is used or not based on a deterministic algorithm. And it will burn CPU cycles. Whereas the coding agent will probably read a lot of documents, reason about it. And these days, in very simple, small repositories, it will probably provide a good enough result. Maybe even equally fast. Maybe not. But it will burn many more tokens. It will fill up your context much quicker. So let's pick up some refactoring that we would like to do. Maybe I'm gonna pick something that we can start with a new chat, paste it here, and kick it off. We never know if we would be lucky to kick off also the agent. And also we won't kick off the agent if we don't restart the codex. So I don't know if that is maybe, but we have seen already that our agent is using the Roslyn compiler services. You can see over here in sources, and sorry for my Polish, but to do this refactoring, we are actually offloading some of the GPU work in the OpenAI cloud back to our local CPU. So counterintuitive direction, but surely a one that would save us token usage. And in some other respects, this can be even beneficial. So what it says that it used intelligence of CSharp Roslyn to use the commands. So what are the scenarios that this Roslyn Intelligence uses? That's actually a nice name. I might use that to rename that repository, because I think it's got more generic name than it should. So let me go to the settings, and you can see some of the MCP servers. You can have the CSharp Roslyn enabled. That's by default. And then we've got some skills. It's all in Polish here. I don't know why, but that's what it is. So what it can do is it can tell you about the call hierarchy, attribute usage, architecture rules, API compatibility, affected symbols, a lot of other things. Event flow, it can find references. That is something that's very, very useful, because on a large code base that saves a lot of traversion of many files that can be either big or numerous, both. And the same one that I'm using quite often is the inheritance graph. It's very, very common scenario. And actually, to use that MCP server, you are not using any API calls to any external services right now. So because you have installed it using the local installer, you don't have to use local installer, by the way. It's all nicely described in the README file, how you can use that without any installation. You can use the PowerShell scripts to do a lot of the things that the installer does automatically. That's absolutely fine. You can even inspect those PowerShell scripts to get it up and running even faster. I think what I did is I basically run a couple of commands initially. Then I kind of like built upon that with a lot of skills that I also wanted to have installed. But essentially, I think I could get away with just 2 commands. The installer is provided for your convenience, but it's either way that not required. And then you've got a lot of explanation around the tools that you are being provided. The difficult part about this implementation is to find the balance between how many tools would be actually useful, and you can have all of them, but that would fill up your context as well. Mind you, using MCP tools is not free. It goes into your context every time you've got them registered and you call them upon a repository. But then you can have very few of them, and you can have a minimum footprint in your context. But then again, that would limit the usefulness. So you can see there is a balancing act between how many useful tools would you like your Roslyn Intelligence to be providing, and how much context would you like to sacrifice for that convenience. Mind you, the goal here is in the first place to save the context space. So there's a delicate exercise with the balancing. The skills are quite important, and maybe in the future there would be also a way of not using the MCP and using just the skills themselves. That would be useful. And for sure, that would be also expensive, because once you are going to use the skill, then the whole skill would probably need to be loaded as well. That would be useful, but I'm not sure if that would save you either speed of implementation or context space. It has to be measured. So what I did here is I actually used a lot of measurements to make sure that I strike a balance between just about useful and really useful on larger repositories. Because mind you, the reason why you would be interested in a tool like this one would be a large repository in the first place. If you've got a code that entirely fits into the context space, and that could be 1 million tokens, maybe more, then you don't really need those compiler intelligence in most of the cases where there's no reflection, there's no this or that. But on a larger repositories, you would definitely benefit from using compiler services and Roslyn Intelligence within your agentic flow, because the amount of documents and dependencies that an agent needs to traverse is actually immense. And that eats up into your context really, really fast. Whereas using just a small and precise compiler directive to, well, just tell me the call hierarchy for this symbol. Doesn't need to load too many documents, doesn't need to do a lot of searches. And mind you, it is very different to search for a symbol name as a text and resolve a symbol name by going through the normal compilation process. Because you can't just search and find. Although, funny thing is, when I was a junior developer, everybody hated because this is exactly what I did. I used the smallest, meanest tool that was really fast with traversing files, even outside the IDE, and used to find symbols that I wanted just by looking for text. And people said like, whoa, you are going to go so wrong about it. But what they didn't know, maybe they forgot, is that I used my intelligence to select the files and the parts of the files that I was interested in. Exactly what RG tools do these days, where if they don't have a compiler intelligence. However, this is all very good up until results fit into your screen, because that seems to be the size of my memory, as I remember when I was coding. But if the number of results exceeds 1 to maybe even more screens, then I would be screaming for a compiler that could do all the heavy lifting for me, because I wouldn't like to go through mentally that many results. And if you are not using any compiler intelligence, so to speak, in your normal agentic flow, this is exactly what happens. You are kicking off the RG tool. It lists you a bunch of matching results that basically it's a text matching exercise. And off it goes. It goes through every single result sometimes. If it doesn't find the right signature from the results, then it has to understand every single file to make sense out of them and to choose the one that actually takes part in the call hierarchy. There's more useful scenarios where this would actually be also applicable. So I was thinking how to present that to you, and I think the easiest way would be just to say that you're basically offloading some of the agentic thinking into local compiling. That can be faster, but in some cases could be slower. Specifically, if you are asking for something that would take a lot of compilation time, because you've got, I don't know, aspect-orientated programming attributes that come into play. But then again, this is also the reason why you would like to use compiler services even more, because the local agent wouldn't be able to figure out AOP just by looking at the class and its attributes and decorators. It will have to actually look a little bit deeper to what these decorators mean, then to resolve that they're actually doing some aspect-orientated programming, and then figure out everything that should happen as a result. Whereas compiler services will basically do that mechanically on your CPU and present to the agent just the result. So this is what was going to happen with this method. And you got the answer maybe more concise, maybe more direct and more predictable in a predictable fashion, but it doesn't mean you'd get it fast. But then again, if a agent gets it wrong, because it didn't include the fact that you've been using AOP, which was slowing down the compiler in the first place, then you would find that much later on, and you would have to do some cycles with fixing bugs or maybe regressions. So overall, this should be a preferred way, because you would prefer to get it right the first time, even if it takes some of your context and some of the processing time. So let me just go back and try to find another example where it is actually being used. One thing you have to have currently installed once you're installing this whole MCP is the latest .NET SDK, but which is assumed because you are going to be working with .NET C# services. But actually, you don't need to have the latest SDK. That could be also the case. For this, you need the latest SDK. Why? Because the Roslyn Intelligence, let's call it, this name actually is going to stick, is in fact built upon the newest version of .NET Framework, and particularly the newest SDK. It actually uses the newest format of the MCP protocol as well. You know that because it actually installs some compatibility layer for some older agents. So it's got a lot of features that enable back and forth communication with the server that might be used in a very specific scenarios. But if you are with the latest Visual Studio, with the latest SDK, with the latest C# language, and modern tools like CLI, GUI, or what have you, it should be good to go. I'm only presenting you the use case with the graphical user interface of the agent. But equally, you can imagine that it's only a wrapper around your CLI. So it trusts your solution because it's already trusted. If not, you have to click here that I trust this solution, because mind you, the compiler is going to inspect potentially dangerous code that you have to trust. Well, if it's your code, then how can you trust your own code? Do you trust your own code, or do you not trust your own code? I suppose the answer is yes, because that's what you have to answer, both in Visual Studio Code and in Roslyn Intelligence Agent. Yep. Oh, there's an error. Yeah, that's interesting. Session trusted. Could be an error. Well, we're gonna see. Lot of chats that I can't remember actually having. Must have been some time ago. So let me maybe kick it off something else. So tell me about the solution. I haven't actually tested it thoroughly with concurrent usages. It should be fine for the reasons I remember, but it's a matter of testing, right? Ah. So a very raw description of what is happening. I'm asking really dumb questions here. Questions that I could have answered with JetBrains Rider, but that's not exactly what your agent is using. Actually, Rider is very good for that. Yep. So yep. So this still eventually worked. And you can find that it already knows about your methods simply by asking the compiler to tell you what it needs to have. So it uses like a structured output that is compatible with your latest and greatest coding agents. That makes it really, really fast to process. Right? Good. So this is it. It's a fast introduction into Roslyn Compiler Intelligence, also known as MCP CSharp tools, whatever the name is. I invite you to visit my repository, more precisely the repository under that URL address. Of course, give a star, because I've got none. Oh no, there's one. I probably started. Ah, that's me. So yeah, I've got 1 star, but one more, and I would be where I need to be. And even more so, I encourage you to, and ask you really, if you may, provide any comment and feedback. Maybe some errors that you've encountered, maybe some enhancement proposals that you would like to make. That would be all very, very welcome. Otherwise, it is going to be a tool that fits my own style and preference, which is already good for me, but I just thought it might be useful for you. So I would be very happy to make it also useful for you, if that is something that would take you further with fewer tokens. I would be very happy to hear that. And definitely, if you're a professional developer, then you would like to make use of Roslyn architecture as a modern compiler and a strongly typed language. After all, we've made all that investments into our skills, into our tool sets, and into our patience sometimes. Not to use that in agentic workflows would be waste, basically. And I'm sure this is the one way of actually leveraging the correct decisions that you've made before in regards to your system architecture and language of choice for your projects. So yeah, hopefully that is going to be something that would be useful for you. Thank you very much.